Okay, so let's take one more example. Let's take one more example on this percentage way of doing calculation. So I don't know, I mean, let's take a very weird example and then just try it out. I mean, 47 multiplied by, I don't know, I mean, you could take anything, 23 or something. Now, this is a very interesting problem because you could look at it in different ways. You could just say that I do it by Vedic math, which is the normal Vedic math way, which is 47 multiplied by 23. So the case you get 21 here and you get 2 as a carryover, then you cross multiply. I don't know whether you watched the video of these doing these fast calculations. So 7 2 is 14 plus 12 plus 2 is 28, so you put a 2 and as a carry, and then you say okay, this is the last step, which is 4 multiplied by 2, which is 8 into 10. Now the thing is that you need to do these 3 steps. So first, second here, and third here, and then you will get this final result. But 47 multiplied by 23 can also be looked up into a different way, and I'm now using percentage method, which is actually something which doesn't really work that smoothly for such calculations. But let's try how it could work. I'll tell you in which cases it will work. For example, it will work really nice when you're actually multiplying numbers with 44, 48, and 52.5, or you're multiplying by 47 and a half, or you're multiplying by 22, 24, 28 and stuff like that. So it needs to be a easily breakable percentage. So for example, now in this one it is 10% on top. In this one it is 20% on top of the base, which is 40. In this case it is, so if you add 10% of 50, it's 5, and then it's basically 5% on top of 50. Here it is 5% less than 50. Here it is 10% on top of 20, and here it is 20% on top of 20, and here it is 40% on top of 20. So yes, in certain cases it works better, and the reason why I'm giving you now this weird example, which is 47 multiplied by 23, is basically to hone your skills to actually do very, very fast calculations. It's nothing, I'm not recommending you to actually use the percentage method in such a case where it is it's such different number. But there are other techniques you could use, just as I showed you, just the normal Vedic mathematical calculation, which is as fast as maybe more fast. So first step is to basically take some approximation. Now what that approximation is, in my head the first thing which I'll think is that 47 is nothing but 50 minus 5%. Well, it's not precisely so, it's 47.5, 50 minus 5%. But yes, if I have to do a rough calculation, I would do it. I would say 50 minus 5%. Let's take that number. 50 minus 5% of 50. Isn't it? Because if you subtract 10, so 10% of 50 is 5, half of 5 is 2.5. So if you subtract 50 minus 2.5, so basically it comes to 47.5. So this number is nothing but 47.5. So you should be really quick when you actually translate yourself from this state on the left to the state on the right. And actually this is not step 1. I should say that this is step 2. The first step is identifying which of the numbers you would use as the percentage number, and then you have to do the calculation. So I've decided that I'll take 47 because it looks easy to me. Then I say okay, 50 minus 5%, and then I multiply it by 23. Now for me it's very easy actually. 23, and so when I look at 50, then I would say, well, 2300 divided by, it's half of 2300, right, which is 1150, and then I just subtract 5% on top. So what it will be 5%, it will be 115 divided by 2, which also I can do mentally, isn't it? If I have to just do a very rough calculation, then it becomes 60, and then my answer becomes what? It becomes 1090. That's not, so 1090 is not the perfect answer, but if you do real fast calculation, you're standing in the shop and you just want to do a very fast calculation, then you could use this method. So what I did then in the third step is actually multiply 50 by 23 in my head. So this was the third step, and in the fourth step I actually subtracted this 5% of 1150. So just quick revision, what are these 4 steps? First is basically to identify which of the two numbers for multiplication you would pick up as the percentage number. The second step is to translate it. I mean, when I look at numbers, I can actually tell you that what translation I would want. So for example, if I look at 48, I can clearly tell you that I'll take 40 plus 20%. So if somebody tells me 48 multiplied 53, I clearly know that okay, 48 is something which I'll take. I'll multiply, I'll take 40 plus 20% of 40 as my percentage number. Here I looked at 47 and a half is the closest number, which is 50 minus 5%. So I took that. That's step number 2. Step number 3 is the multiplication with the easier part. So the easier part here is multiplying 50 by 23. So which I did mentally, which is basically, I said 2300 divided by 2 is 1150, and then I just removed 5% from the number. Yes, so this is the way to do the calculation percentage method. As I said, I mean, for this particular case, it's not that easy to actually do it via percentage method. It's much easier to do it the normal Vedic method way. But you have to decide, when you look at multiplication of two numbers, you have to decide which way you want to do it. Yes, the next one I actually talk about percentages, 2 special percentages, which is 7% and 14%. And this will be really useful when you're doing calculations where it involves numbers which are in multiplication of 7. So see you then. Ciao. Okay, so let's talk about very interesting numbers, 7%. And I'm just taking rough approximation. 7% is 1 by 14. And 14% is 1 by 7. It's actually very interesting. You know why? Because whenever you look at, I'll give you one example because I'm from India, and the value of Indian currency is actually 1 euro is equals to 85 rupees. Now I all the time have to do this calculation, that I have to always multiply by 85. But how do I do it? It's quite easy, because whenever I look at numbers, so for example, if I look at a shirt which is 23, let's say 21 euros, we'll do 23 in a later case. So let's say it's 23 euros. Then what I would say is that if I have to calculate the normal way, then I'll multiply it by 85. And if I'm standing on the shop, it's very difficult for me to do the multiplication. What could be an alternate? Let's assume, now this is the pie. The pie didn't look that good. Anyway, this is the pie of 21 euros. And I have to translate. And let's say that, and I have to multiply by 85. So let's say that if I break it down into 7, anyway, it might not look equal to you. 1 2 3 4 5. And if I break it into 2, 1 2 3 4 5 6 and 7. 1 2 3 4 5 6 7. So 7 pies, right? So I broke the pizza down in 7 pies. Now the thing is that if I remove one of the pies, and on all these pies are actually equal, are absolutely equal, doesn't look that cool on the video, but all the pies are equal. If I eat up this one pie, what does it mean? What it means is that I had 100% of pizza in the beginning, and then I ate away 7%, 1/7 of it, because it's 7 pies. So I ate away 1/7 of pizza. So what does it mean? So I would say 100, 1 minus 1/7. If I know that 1/7 is 14%, then I know that basically it is 86%, right? Multiplied by 100. So you could remove this percentage. So this is also clear in my head. Now if I have to quickly multiply 21 by 86, then I can do what? I can just multiply, I can just say 2100 minus 2100 divided by 7, because I have to just remove the 7th pi to actually multiply any number with 86, right? So just have a look at this, just try and form the link. So 21 euros was my shirt. I had to multiply it by 85. I just took an approximation of 86. So 85 and 86, let's assume they are very close. So whenever I look at a shirt which is 21 euros and I have to convert it into Indian rupees, and I would just say 2100 minus 21 by 7, or basically I just remove the 7th pi. So 21 divided by 7 is 3 euros, so 1800. So I would just quickly say 1800. So in my head, 21 multiplied by 85, or to be precise, or could be, let's say it's just 86, it's rough approximation, right? And it's pretty close. I mean, 85 and 86 doesn't matter for doing approximate calculations really fast. So I just remove one pi out of it, the 7th pi. So 21 divided by 7 is 3, so 1800. So I quickly know that it is 1800. Let's take another example where my shirt is now 42 euros and the exchange rate still stays at 85. What do I do? What do you guys think? So I just remove the 7th pi out of this 42, which is basically 6. So 42 divided by 7, which is 6. Yeah, and then I know that the shirt costs me 3600 roughly. And let's take another example. Let's take I don't know, 77 multiplied by 85. Now this is a pair of this is, let's say, a coat which I'm trying to buy. So I just remove the 7th part of it, which is 11. So I remove 6. So I just get 6600. It's a fair approximation, actually. It's a very fair approximation. It's actually an exact calculation if you want to calculate 6/7 portion of 77. Now you could use it in many ways, actually. If you were to just if the shirt was 45 euros and not 21, if you were to do this calculation again, it's pretty simple, right? I look at the table, but the thing is, the table of 7 should be really clear in your mind, right? So when I look at 45, I would say, yeah, okay, 45 is what? 45 is what? It is 42 plus 3. I can also say 42 plus 3.5, which is also a half multiple of 7. And then I can do the calculations backwards from there. Or if my shirt costs 28 and I have to multiply it by 85, then what do I do? I would just say, okay, I just remove the seventh part of it, which is seventh part of this is 4. So 28 minus 4 is 24. So my shirt would cost roughly 2,400. So this is a very quick and dirty way actually to do for really fast calculations, which is using these percentages with 14. So you have to remember this. This is actually a very, very cool trick. 7% is equals to 1 by 14, and 14% is equals to, and you can play around with a lot of such calculations in your head. And I just took one example of euro to Indian rupee exchange rate and then gave you some examples, but you could also take many other examples and form your own rules and formulas and play around with this. This is a very cool way to actually multiply numbers. Now, for example, if you have to multiply, it's actually a good way to divide numbers also, and we'll take it up in the next few videos. But I would just say that just look at this now. 7% is equals to 1 by 14, and 14% is equals to 1 by 7, and then just apply it whenever you get a chance to do so. See you in the next video where we'll talk about 9% thing. Till then, ciao.